Hello, statistics students. Welcome to another video on the linear regression model, checking linearity. If the trend in the original data is linear, then the residual plot should have no slope. In other words, the residual plot should have a flat trend. For example, figure 14.4a shows a scatter plot for the larger collection of books. Width is plotted against length measured in terms of number of pages. Remember, we're using the number of pages to predict the book width. The regression line has been added to help you see that the trend is linear. Figure 14.4b shows the residual plot. The residual plot has no trend. This is good because it indicates that the first condition of the linear model is satisfied. When the trend is nonlinear, as it is for the relationship between the heights of the tallest buildings in the world and the number of floors in those buildings, shown in figure 14.5a, the residual plot on the right will display some sort of trend or pattern, as you can see in figure 14.5b on the right. Now, this is an interesting example because on the left, you see the line. It kind of looks like that line fits pretty well. That's a linear relationship. But when you look at the residual plot, you see that it has this positive trend to it. And so that indicates that a linear model is not the best fit for the data. And then when you look back at the data, you see a lot of points clustered below it, which means it is a non-linear relationship. So the residual magnifies that lack of linear relationship. Key point, if the first condition of the model, that the shape of the trend be linear, is satisfied, then the residual plot, a scatter plot of residuals versus x values, will have no slope, no association. You may be wondering why we need a residual plot to tell us whether a trend is linear or nonlinear. Kind of alluded to that in this figure. Can't you just tell by looking at the scatter plot? It is true that in many situations you can tell from the scatter plot, but the residual plot serves as sort of a microscope and makes it easier to see subtle nonlinear patterns. Figure 14.6 shows data collected by Dan Teague, an instructor at the North Carolina School of Science and Mathematics. He filled an urn with lemonade, opened the urn spigot, and recorded the depth of the lemonade in the urn over time, measured in seconds. At first glance, the trend looks fairly linear. But now consider the residual plot in figure 14.7. We see a distinct trend that is nonlinear. The residuals show a very strong trend. The residual plot highlights the deviations from a straight line that are hard to see without very careful scrutiny. Look back at figure 14.6 on the right there, and now you can probably see that the points do not exactly follow a straight line. In fact, they follow a quadratic curve. But without the residual plot, we might not have noticed that these data do not satisfy the linearity condition. Hence, the residual plot is very useful. And this concludes this video on the linear regression model, checking linearity.